Three circles are overlapped in a way such that the centers of the circles are located at the exact same points where the edges of two circles are intersected. The question is, what is the area of the shaded region? Okay, so first we are gonna find out all three of the centers of the three circles. So this point over here is the center of circle A, as this is an intersection point of the edges of two circles, and as this point is located inside circle A, uh, same thing here. This is an intersection point of the edges of two circles, and this point is located inside circle B, and that's why this point over here is the center of circle B, and this point over here is the center of circle C, as this is an intersection point of the edges of two circles, and as this point is located inside circle C. Okay, and now I'm gonna explain you guys why all three of these circles are equal in size. So I constructed a straight line segment from the center of circle C to the center of circle A, and as you guys can see here, this straight line segment is a radius of circle A, and as well it is a radius of circle C. And as this straight line segment is a radius of both of these circles A and C, the lengths of their radiuses are equal, and also uh, both of these circles are equal in size, as the lengths of their radiuses are equal. And also circle C is circle C and circle B are equal in size. We can prove that using the same concept. And also circle B and circle A are equal in size. All three of these circles are equal in size. So that's how we prove that all three of these circles are equal to each other in size. So now we are going to solve for the area of region X. First, we are going to construct three straight line segments combining all three of the centers of the three circles, like this, as I am doing here. And secondly, and now we have constructed an equilateral triangle. As you guys can see here, this is an equilateral triangle. The mathematical reason why this is an equilateral triangle is because the sizes of all three of these circles are equal, and therefore the lengths of their radiuses are also equal to each other. So this is the radius of circle A, and this is this also a radius of circle C, and this is a radius of circle B. This is a radius of circle. This is a radius of circle A, and all three of these lines are equal in length, and that's the reason why this triangle is an equilateral triangle. So as this is an equilateral triangle, the magnitude of this angle over here is 60 degrees. Okay, and now I want you to forget about this straight line segment constructed by combining the center of circle C and the center of circle B. Just forget about it, and I want you to concentrate on this diagram. So as you guys can see here, this shape is a circular sector. So we know how to solve for the area of a circular sector. So the magnitude of the central angle of this circular sector is 60 degrees. So we can simply solve for the area of the circular sector using the formula pi r squared times theta over 360. And now we are going to reconstruct our straight line segment that we've erased. Okay, so now as I mentioned before, this figure is an equilateral triangle. So we know how to solve for the area of an equilateral triangle by knowing the side length. If you don't know how to do that, don't worry, I will explain that at some point in this video. So we can easily solve for the area of this equilateral triangle and subtract that value by the area of this circular sector and obtain the area of this shape. So there are three such shapes in region X. So um, now now again I want you to forget about this straight line segment. We are gonna erase it. I've already taught you how to solve for the area of this region, and there are two such regions. So by multiplying the area of this region, uh, let's call it region X, let's call it region L. By multiplying the area of region L, or else the shape L, area of the shape L by 2, and by adding that value to the area of this circular sector, we can solve for the area of region X. So this and this, both of them are region. Both of them are L shapes. Not L shapes. We are just that's just an algebraic letter. So um, that's how you are gonna solve for the area of region X. And now we are gonna solve for the area of region Y. So how we are gonna do this? So we have already calculated the area of region shape L, and uh, we don't need to calculate it again and again. We know the value of the area of shape L. So using that, we can easily solve for the area of region Y. So first I'm gonna construct a few straight line segments as I did before when solving for the area of region X. And as you guys can see here, this is an equilateral triangle, and the area of this equilateral triangle plus the area of uh, area of area of an area of a L shape times 2 minus the area of a L shape gives you the area of region Y. So that's how you solve for the area of region Y. We remember this part does not belong to region Y, it belongs to region X. So that's why we subtract the area of a L shape by the sum, area of an equilateral triangle plus the area of two L shapes. That's why we subtract the area of one L shape by that sum. And that's how we solve for the area of region Y. And now we are gonna multiply the area of region Y by 3 and add that value to the area of region X, and that's the solution for this problem. That's everything that we need to do to solve this problem. And now I'm gonna teach you how to solve for the area of an equilateral triangle by only knowing the side length. Uh, that's what I'm gonna teach you now. Okay, so let me construct an equilateral triangle. Okay, this is our beautiful equilateral triangle. So let's suppose that this equilateral triangle has a side length equal to x, and now and this line segment over here is the height of this equilateral triangle. Height is the length. The height of an equilateral triangle is the length of the line that is drawn from the top of the triangle to its bottom perpendicularly. So this is how we are going to so first we are going to calculate the height of this triangle. So we are going to do that using the Pythagorean theorem, and then we are going to solve for the we can easily solve for the area of this equilateral triangle by multiplying x by the value of the height and dividing that value by 2. We can use the formula 1/2 base times height. So so when we take an equilateral triangle, it has three axes of symmetry. So this is one of them. So this line segment over here get divided into two equal lengths, and the length of this part is going to be x divided by 2. So now, as you guys can see here, this is a right angle triangle. Let me color it and show to you. So I'm talking about this right angle triangle. So this is a right angle triangle, so we can use the Pythagorean theorem and solve for the height. So this is x is the hypotenuse, so we can write down a simple equation. So the height is equal to, or else this length is equal to x squared minus minus the length of this line segment over here squared. And now we are going to remove brackets and simplify this quantity, and when we remove brackets it becomes x squared divided by 4. The reason why this quantity becomes x squared divided by 4 when I remove brackets is because as I remove brackets, by removing brackets, I will have to square both the denominator and the numerator. So x times itself becomes x squared, and 2 times 2 is 4. So x squared divided by 4. So now let's simplify this thing a little bit. So so when we take a whole number, or else when we take a number, if there is no denominator, it means the denominator is 1. So the denominator of this quantity is 1. So now we can simplify this. It's really easy. And now when 4 is common, for 4 is the least common multiple of 4 and 1. So we are taking 4 as the denominator. So I will have to multiply the denominator of this fraction by 4. So as I multiply the denominator of this fraction by 4, the numerator will also get multiplied by 4. Otherwise the value of that fraction will change. So 4x squared divided by 4 minus 4 x squared minus divided by 4. So so 4x squared minus x squared becomes 3x squared, and this thing simplifies to be 3x squared over 4. 3x squared over 4 equals h. sorry, not h, h squared. Okay, I made a simple mistake. It's not h, it's h squared. Okay, and now to get rid of the square, we solve for the square root of this quantity. We solve for the square root of both sides of this equation. Okay, and by doing that I can solve for the value of h, and now you can plug in the value of x and simplify things and solve for the square root and solve for the value of h, and that's how we solve for the height of an equilateral triangle. And then by multiplying that value by the base, by the length of the base of your equilateral triangle, and dividing that value by 2, you can solve for the area of the equilateral triangle. So for an example, if we take an equilateral triangle with the side length equal to 1, the uh, the uh, the 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 height of that equilateral triangle is 3 over 4, 3 over 4 root, the square root of 3 over 4. So we can remove brackets, and we can get rid of this root by solving for the root of both of these numbers. So the square root of 3 is just the square root of 3, is not a whole number, and the square root of 4 is 2, and the square root of 3 divided by 2 is the height of an equilateral triangle with a side length equal to 1. So that's how we solve for the height, and now you can solve for the area by multiplying this value by 1 and dividing that value by 2, or else multiplying by 1/2. So that gives you the area of an equilateral triangle with a side length equal to 1. So that's all for today. Hope you enjoyed this video. So see you guys in a future video.